When should we use not implemented in Python? Integers and floating point numbers can be compared with equality. This is powered by the Dunder EQ method. But strangely, if we call the Dunder EQ method on an integer, giving it a floating point number, we'll get back not implemented. But if we do the same thing on a floating point number, giving it an integer, we get the answer we're expecting. The same thing happens with many other operations in Python. For example, the plus operator is powered by the Dunder add method, and floating point numbers can be added to integers, but integers cannot be added to floating point numbers. What is this not implemented value, and why do we get it? So Dunder methods that perform an operation between two objects are expected to return not implemented when the first object doesn't know how to perform that operation on the second object. So when we add a plus b here, Python first goes to a, which is an integer, and tries to add it to b. That integer returns not implemented. So it then goes to the floating point number, b, and tries to call the Dunder add method with a. So not implemented is basically a way to signal to Python, I don't know how to perform this operation, go ask the other object instead. Python then asks the other object to add itself in the right-hand side, and it gets the answer it's expecting. So Python first asks the left-hand object to perform an operation. If it gets this special not implemented value, then it asks the right-hand object instead. That means when we're implementing our own Dunder methods in Python, if we're given another object that we're supposed to operate on, we should check the type of that object to see whether it's a type that we know how to operate on. Even though we typically use duck typing in Python, this is one of the few cases where we actually practice strong type checking. We're asking this other object, are you a duration? And if it's not, then we return not implemented because we don't know how to compare ourselves as equal to it. So duration objects can be compared to other duration objects here, but we can't compare durations to integers. What Python does in this case is it tries to call Dunder EQ on the duration, giving it the integer. Because it gets not implemented, it then tries to compare the integer to the duration. Since it also gets not implemented there, it returns false. If we were doing something that wasn't equality, maybe it was addition or less than, it would raise a type error instead. Now, what if instead of returning not implemented, we returned false here? We decided that any object that is of a type that we don't know how to compare to, we just aren't equal to. What's the downside of this? So the downside is really inconsistency here. If we ended up with an object that can compare itself to equal to us, like this very strange object here, always equal, which is always true, it's always equal to everything, then we'll have a bit of inconsistency when we compare for equality. So an always equal object will always be equal to another object, but our duration will not be equal to it. So while b is equal to a here, a is not equal to b, which is kind of strange. So we're expected to return not implemented to avoid this scenario, to make sure that Python properly knows to delegate to the other object just in case it knows how to compare itself as equal to our object. When implementing a Dunder method for an operation that works on another object, you should return not implemented if your object doesn't know how to perform that operation on the other object.